Good afternoon, good evening, good morning to everyone. Thank you for joining us. I am your host, Jared Burns, and we're here to talk about the latest efforts between Capewell and Pennant to provide training for the Loadmasters on military cargo aircraft. Next slide. The schedule for today is to go over a little bit of the background on how this system began and explain our objectives to conduct training for Loadmaster aircrew. We'll spend 30 minutes going through some slides and some video. Now the video may appear a bit choppy because of limits to the bandwidth. We will be recording the entire presentation to send later on if you want to share it or review it with a better connection. And at the end, we'll have 15 minutes to talk about questions, to take your comments. Please don't wait to put your questions down at the bottom. We can take them and we'll address them towards the end. And if you have any other comments or suggestions, we're open to hear anything you have as far as the feedback for this webinar. Okay, next slide. So I'm the Director of Operations at Capewell Aerial Systems. We're based in South Windsor, Connecticut in the US. We have another location in Meadows of Dan, Virginia. But myself, I've been here for 8 years. I spent some time in the Air Force flying and some time as an instructor. So I know a little bit about flight training and I know a little bit about simulator training. And I'll let Stuart and Tom introduce themselves.
Thanks, Jared. So before I start, I'd just like to thank Jared and the wider Capewell team for inviting Pennant to participate in these webinars. It really is great to be able to jointly showcase the product. Moving on to myself, I'm Stuart Hooker, part of the business development team for Pennant International. I've been with the business for over 15 years, and during my time I've held a number of different positions. Those roles have enabled me to obtain a great understanding of the business and the wider industries we operate in. I'm currently the nominated account manager for VLTS and have the pleasure of working closely with Jared in the ongoing development of the product. I'd now like to hand over to Tom to introduce himself.
Thanks, Stuart. I'm Tom. I've been at Pennant since 2016. I've 10 years experience working in software development. I started out as a 3D artist and quickly moved into programming for networking, simulation, training applications, and virtual reality. I've been software lead for many projects at Pennant, including the ones we're talking about today.
So here's the obligatory who we are. If you don't know Capewell, we've been around since 1881, supplying the military with equipment. We've evolved into delivering equipment, designing and manufacturing airdrop solutions, basically being a world leader when it comes to dropping personnel or cargo out of the back of aircraft. And because of the experience, we've also been involved with training crews on conducting airdrop missions. Slide.
So Pennant was established over 60 years ago in 1958. Over the years, we have evolved to establish ourselves as a market-leading, technology-driven company that specializes in a range of training products and services, primarily within the defense sector. Our headquarters are here in the UK, but we also have operations within North America and Australia. Some of our capabilities include the conversion of full-size aircraft into high-fidelity training aids, immersive virtual reality solutions. We have a range of modern, generic part-task trainers and smaller procedural trainers. You can see some pictures of those below. Interactive 3D courseware and media, and our integrated product support division has market-leading software tools that record, manage, and analyze technical data.
So you may be wondering why these two companies are partnered together. It's really because it was a really good match between our subject matter expertise at Capewell with the airdrop mission and the Loadmaster roles and responsibilities, and Pennant's expertise in simulation and computer-based training. Between the two of us, we saw a need for something new that would allow Loadmasters to conduct simulator training in a way they've never been able to do that before. So this is really a 50-50 partnership of us both bringing our strengths to this effort. Slide. So the result of our partnership over the last few years has been this Virtual Loadmaster Training System, primarily designed with the idea that we can provide emergency procedures training in a way that there's no real world ability to do so on a plane or any other training event. So we want to increase the safety and the training effectiveness for the Loadmaster position, and hopefully bring a new capability to the Air Forces all around the world. Slide. So the main inspiration for this whole simulator was an event that happened in 1989. It was a training airdrop. The mishap resulted in the fatality of one of the Loadmasters because they were dropping a very heavy payload, which became jammed on the way out. The way these payloads are extracted, they use a large 28-foot parachutes to pull the payload out the back. And those parachutes are big enough and they provide so much drag that it's possible to bring the entire plane down if they get stuck. And that's unfortunately exactly what happened. There was too much drag on the plane, it crash landed, and one of the Loadmasters was killed while attempting to cut the parachute loose and trying to save the plane. And one of the results from the investigation was that there's really no training for this scenario that existed because it's way too risky to try to recreate this in the actual air. And the only way they had to sort of rehearse this scenario was to just talk about it up until now. Slide. So that mishap kind of highlighted one of the training gaps that exists between the pilots in the front end and the Loadmasters in the back end, where all the cargo handling is done. I'm sure you're all familiar with the very expensive, elaborate systems for cockpit trainers. They have full motion hydraulics. Every cockpit switch is recreated to 100% fidelity, and the crews get to interact with each other in the exact same way they would by talking, just talking to each other or over simulated radios or intercom. And it's very, very good training. You compare that to what's available with Loadmasters, if there's anything for a simulator, it's often low fidelity. You're dealing with flat panel screens, touch screens, interfaces that don't really represent the actual systems on the aircraft. And there's very little immersion. There's no sense of movement or being able to see what's around you. It's a completely different type of quality of training for the Loadmasters compared to the front end. Slide. So one of the problems with this is the way that flight training is often done. They've spent a lot of time in ground school, learning the books, learning about the systems, and then you go right to the flight line where you try to apply all that knowledge you've just learned in the classroom. And anybody who's been through flight training knows that those first few flights are very hard to comprehend anything because there's so much new information coming at you. It's hard to retain any of the new information that you get. And oftentimes you'll hear the term a helmet fire. The student is just way behind and they're doing all they can just to get through it rather than being a really effective training. And the learning theory behind this is the comprehension phase is what's getting skipped over, part where you can drill something in your head or you practice it over and over again before you apply it in the real world. This is a big step in what VR can offer because you can drill these procedures over and over and you go from the knowledge phase to the comprehension phase seamlessly so that your application phase is much more effective. Slide.
VR is a product of the gaming and entertainment industry and its emergence into military training is an example of the role commercial technology has played in expanding military capability. There's previously been general caution within the military world to introduce consumer technology that might be considered by some as rather lightweight in comparison to the reality soldiers face in operations. Can this technology really replicate the anxiety, fear, and difficulty of live operation? Does it enhance the training, or is it purely a use of technology just for the sake of it? Here is an example of where 13 students went through an experimental pilot training program. The students that were offered the enhanced VR experience were able to reduce their overall training time and enable them to practice more complex routines far earlier. Over the years, simulation has transformed many aspects of individual and collective training. Synthetic environments such as pilot simulators have reduced the need for complex, costly, and risky live exercises and delivered high-fidelity training with accurate definition and realism. One of the key advantages of virtual reality is the ability to immerse users in a virtual yet safe environment. There are already a number of examples where the cost benefit swings in favor of the virtual training. For example, the cost of using real aircraft and assembling the personnel to simulate an operational scenario far outweighs any investment in the virtual training technology.
The hardware we're using is some of the latest consumer off-the-shelf virtual reality kit and computers. The whole thing is run by very powerful computers to allow for extremely realistic and high-fidelity visuals, as well as local network support to allow multiple Loadmasters to communicate and work together, while being monitored by an instructor all in one scenario. VLTS supports open VR headsets such as the Valve Index and the Vive Pro, the latter of which can be used in conjunction with a wireless kit for extra freedom of movement. Both of these headsets are extremely high resolution and have a refresh rate of 90 frames per second, giving the user a very realistic and immersive experience. We support the Vive controllers as well as the Valve's Knuckles controllers. The Knuckles track each individual finger's movement, allowing for accurate interaction with the environment, as well as the ability to communicate with other Loadmasters through hand signals. Both of these headsets support full room scale tracking. This means if you have the space, you could walk the entire length and width of the plane's footprint in VR without the need for any locomotion systems such as teleporting. So this brings us on to training footprint. If you don't have the space to cover the entire plane's footprint, we recommend a VR area of 3 meters squared, as this covers the width of the C-130 with the teleport system covering the rest of the area. The VLTS does support standing room only, so it can be scaled to fit in almost any space available. As previously mentioned, the hardware is essentially a VR headset, some PCs and monitors, and some cables. This makes it extremely portable. The whole rig can be set up and packed away very quickly and can be stored in a very small space, especially if you use laptops. Back to Stuart.
So one of the most common criticisms is that the VR solution is not considered to be realistic and contains certain tactile limitations. However, where the technology is used appropriately, it's proven to add significant value to training. Pennant have already developed other VR-based training products, including a parachute trainer and a mastering trainer that have been in service worldwide for many years and proven to add significant training value. You can see from the quote on the screen that this is a shared view within senior military figures.
So taking everything we know about VR and what we know the Loadmasters would like to have, we came up with a wish list that a system would have to have high fidelity visuals. It would have to focus on emergency procedures that couldn't be done in any other way. And you would have to interact with the aircraft like you would normally do on the real thing. And the scaling of the difficulty would allow you to train brand new students from the schoolhouse all the way to a veteran instructor who may be evaluated on their teaching technique. And of course, most importantly, it has to be affordable so that units can purchase this with the unit level funds for every location they may be at. Slide.
Here you can see a list of the current features that are contained within version 1 of VLTS. Currently, we have modeled the C-130H aircraft, which is the ability to deploy heavy equipment such as a Humvee, along with single and dual CDS loads. we're able to provide a range of scenario features, including the ability to adjust time of day, weather conditions, and custom flight routing. Geographically specific terrains can be modeled to represent operational procedures, and all of the training content is recorded for an after-action review and debrief. Jared will now discuss some of the other features in more detail.
So primarily, we wanted this to be a very good emergency procedures trainer. So there's a lot of focus on identifying and recognizing malfunctions when they first occur, because like I mentioned in the scenario before with the hung load, Loadmasters may never see that until it happens for the real time. And we want them to be able to practice identifying it as the first step. The system will record and measure performance and log key events throughout the mission. And then you have a capacity to do a full review of the entire video from the student's perspective. So if there was a problem or a student made a mistake, the instructor can go back and review exactly where they were looking at what time to sort of identify where they went wrong. Next, we're going to show some short clips that demonstrate all these. Again, the videos may be a bit choppy, but if you've got any questions, please just go ahead and put them in the Q&A section on the bottom. So this scenario is showcasing what a hung load would look like. The first step for the normal airdrop preparation is to detach the restraint chains. The Loadmaster is communicating that they're going to inspect the side rails. So they each check the left side and the right side. Now they're checking the parachute in the bomb rack. And they'll go back towards the front of the aircraft to open the side lock covers so they can inspect each of the locks as they unlock and prepare for the drop. You see them grabbing the covers very easily with the natural controls. You just grab on your hand and the controls recognize the grip. They're preparing the override handle in the event that the load gets stuck. That is the first step in trying to release it. He's instructed the student to start unlocking each station. So you'll see the lock start to move, going from the foreground to the background. And because the covers are open, he can visually see the locks have disengaged. So now the load is ready to deploy. They'd be communicating with the front station, giving the countdown, just 3, 2, 1 to release, and the front station releases the deployment parachute. You see it there. The load doesn't move, so they recognize the hung load and attempt to override once and twice. Still doesn't work. So they communicate to the front station that there's a hung load. He directs the secondary Loadmaster to put the restraint chains on while he tethers himself as a safety precaution, because he's going to be going back towards the tail. Once the restraint chains are on and confirmed, they can safely move back to the back of the aircraft and use the hook blade knife to cut away the extraction parachute. And that would be a successful event for a hung load. So you can see in that scenario, the instruction was pretty much wide open to develop as the instructor desired. They could basically tailor the scenario to the experience level of the student. They could interject different problems. They could change the time of day. They can reset the scenario to start over from where they made a mistake. Basically, there's a lot of flexibility in how the instructor runs the simulation. We didn't want to give you only a scripted event. In my experience, the instructors prefer to have a lot of options on the way they run a training scenario. Next slide. This video demonstrates how effective nonverbal communication can be. So we're highlighting the hand tracking and the finger tracking of these second generation controllers. This Loadmaster is telling the other Loadmaster that their intercom is down, that they can't speak. So he's going to basically gesture and communicate with his hand signals and body language. He's directing his attention to the side lock And this may be an instructor who's not happy with the student's performance, and he's giving him one last chance to fix the problem. But this, again, is something, another curveball or another challenge the instructor could throw at a student by limiting their ability to communicate, as it could really happen in the actual flight. Next slide.
Jared, it's probably worth noting at this point that some of these features are still in development, so the graphics aren't quite 100%.
Yes, I should have stated at the top that these are a pre-alpha. This is a sneak peek, if you will, at these, and this is not the final implementation. There's a lot of work to be refined on the graphics, but the concept is what we wanted to show today. And that was a great demonstration concept for the crew resource management. Basically, where two Loadmasters can work together. The instructor can literally stand over the student's shoulder and point things out. They can help them through the procedures by their side, or even you could take two experienced crew members and have them rehearse a very difficult scenario that may be prepared for a complex real-world mission. There's a lot of options here to practice working together, which is a unique capability of a simulator like this. In this demonstration, you'll see this is a special forces type payload. It's a Zodiac boat on a combat expendable, and it's a night drop, so they'll be using night vision goggles. The lighting is very dynamic, so the flashlight works very naturally. You can use it to inspect the payloads, and the next step would be to open up the doors and confirm the drop zone. So he's giving a thumbs up to the secondary Loadmaster. He's going to don the MVGs by grabbing above his head, just like he would a regular pair of MVGs. And everything in the real world is modeled, so you can literally look out the back to identify the initial point prior to the drop. And that's confirmed. They'll move back towards the front to prepare for the drop. He's going to get his hook blade knife ready to go. In this scenario, the payload is dispatched by cutting the forward restraint. You'll see them get into position. And the next thing he's waiting for is the green light. So that simulates the front station commanding the green light. And you'll see that on the right of the screen. Right there, it's a green light. Cuts after the forward restraint, and the payload rolls out the back. Last step would be to confirm a good parachute. So they move to the tail and verify a good shoot. And that completes that type of drop. So on this slide, you'll see that this system is already in place with the Air Force at the Connecticut Air National Guard. They've had it for about a year, and we've been learning a lot from their use. In fact, a lot of the feedback and improvements made to version 2.0 come from their comments. They've got the first generation of hardware there, so we've upgraded to the more tactile and hand tracking system you'll see coming up. And they've got a system in the background called the Multi-Mission Crew Trainer, which is a cockpit simulator that 15 Air National Guard units have purchased. And they're experimenting with running the Virtual Loadmaster simulator literally in the space behind this so that they can do a mission in parallel. Whatever they're doing in the front station, they'll mirror in the Virtual Loadmaster Trainer so that they can have a complete crew training event. And that's something they'd like to see more integration with. So we're looking into that as well, future development. And the most number one item for feedback is they wanted more options to do container delivery system drops and personnel airdrops. And that is what is the primary focus for version 2.0. So here is an example of the extra features in the container delivery system drop. Per regulation, the Loadmasters tethering themselves for safety. They've noticed that the door is not locked properly, so they manually operate the door to get the yellow flag to indicate it's locked. and the student tosses their checklist on top of the bundle, and we'll demonstrate some of the 3D excuse me, 3D physics. So the knife they can actually toss around, and they accidentally threw out the back. So now they have no way to cut the strap to release the payload. So they've gone to the front of the bulkhead to try to trigger the knife with the overhead switch, but unfortunately they've misidentified which switch and it doesn't work. So the last resort is to grab the overhead cable and yank on it. So they literally pull down once they grab it, and the knife cuts the strap so the CDS bundle can go out. The idea here is that this student has made a number of mistakes, but the instructor can allow them to proceed and see what they do. Normally, you would have to stop the students at a certain point on a real flight, but VLTS allows you to let them go further and learn from their mistakes.
Okay, so aside from the visual and performance upgrades we've undertaken, we are also adding some new features to version 2. So as you've just seen, we've improved the CDS loads with fully simulated static lines, meaning deployment will now look correct even if the student doesn't fully lower the anchor lines. We've also added a single CDS bundle, as well as the ability to trigger the guillotine by pulling on the overhead line. This, along with the pre-existing ability to cut the straps with the knife, gives lots of options in dealing with the deployments not going according to plan. The largest addition to this version is the ability to train Loadmasters for personnel airdrops. I believe Jared's got some very early footage of that coming up as well. This includes fully simulated AI jumpers, safeties, and jump masters, giving the Loadmasters the ability to train an entire personnel jump from start to finish, including jumpers on tow, both awake and unconscious. It allows them to be recovered or cut away. We've also added more faults to the plane, such as fluid leaks and improved simulation of the auxiliary hydraulic system to allow for low pressure caused by pump failure, manual control of the cargo ramp and door.
So this demonstration is showcasing the fire and emergency procedures. The Loadmaster notices that the payload is smoking and then actually catches fire. They recognize the problem, and the first step is to go to the bulkhead to retrieve the fire bottle. And then they will spray the fire in a wide arc at the base like they're trained, and the halon will extinguish the flames. But their day is not over yet, because the pilots recognize that there's a problem with the engines, so they've asked the Loadmaster to visually inspect all of the engines for any problems. He may be looking for a fuel leak or hydraulic leaks. Nothing wrong on the right side, so they move over to the left side, and sure enough, there's #1 engine on fire. It gives the communications to cut the engine, and so the pilot feathers the prop and extinguishes the flames per the emergency procedure. This next video, very early footage for paratrooper implementation. So you'll see the Loadmaster prepare the troop door. First thing they do is open it up, and then they'll pin the door so it's safe. They're also doing the inspection, checking that the area is clear. They deploy the jump platform, lock it into place, and confirm that the air deflectors, which are not visible from this angle, but the air deflectors are deployed. That's something that the instructor at the control console can control from the touchscreen panels. So here you'll see that paratroopers are getting up, and they'll move to the door. This part is a bit scripted, because it just follows the strict procedures for paratrooper static line jumps. They run through their equipment checks. We'll be adding the sounds of all the jump master commands and the paratroopers themselves. You'll notice that this camera is in a fixed position. This is another feature of VLTS where instructors can observe from a third-person point of view. if they wanted to just see something from a static angle. Next slide. So our ultimate goal for version 2.0 is to get the simulator certified to count for training, so Loadmasters can sign off events that they're required to do on a periodic basis. In the US Air Force, this is called the Ready Aircrew Program, and pilots can do half of their takeoff and landing events in a simulator, which saves a lot of money on wear and tear, a lot of flight hours, and the Loadmasters do not have any option to do that right now. So the goal is for Air Forces around the world to be able to use this as more than just a training aid, more than just a teaching tool, but to actually save on their operational budgets. Slide.
So as regards to a roadmap for future versions of the software, at the moment there is no confirmed roadmap as to what specific features will be included in later versions. However, some initial thoughts that we've had are the inclusion of additional fixed or rotary wing aircraft, to expand the training capability to include wider ground handling functionality, for example, loading, unloading, including load planning and weight distributions, helicopter sling loads, threat countermeasures, the introduction of mixed reality to enable a blend of hardware interaction, adapting certain features to provide civil aviation training compatibility, or military procedures that are specific to other individual nations. Ultimately, what we are hoping to achieve is to build a wider user community that will enable the product to be developed correctly to provide a valuable training asset.
So that concludes the formal presentation. Go ahead and start putting your questions down if you haven't already. Here is our contact information if you want to follow up with us offline. We're going to switch it over to a live video feed of the instructor console, and we'll start taking questions.
Okay, so the first question we've got is one that we get quite a lot, is are there any plans to simulate the C-17?
We have plans to simulate the C-17, but that really depends on what the end users want to do. Everything up to this point has been self-funded between Pennant and Capewell, and even though we have planned to expand this to other airdrop platforms such as the C-17, that will depend on funding. Tom, would you want to hazard a guess as to how long it might take to model the C-17?
Okay. Have any evaluations been performed for any other hand controllers or haptic devices? If not, are these planned? So we started off with the Vive controllers, which weren't, well, they worked well in terms of the hand tracking and everything, but you didn't get the sort of haptic feedback and the finger tracking. So they weren't as immersive as the knuckles that we're using now. The knuckles have got a very complex haptics system in that we've created that basically lets you know when you're touching objects, when you've picked things up, when you've dropped them. That makes it very easy to kind of to even interact with things without looking at them once you kind of become used to where they are. And we have tried sort of gloves that track your fingers as well. And although we did have a version where they worked very well, the haptics in them weren't very good, and some of the interaction is actually better having buttons and things in your hands. Like the teleport, for example, if you can't walk around the whole plane, it's actually the teleport is much easier to operate by pressing a button on a controller than it is for doing sort of a hand gesture or something. So the knuckles are kind of the best sort of middle ground we found so far between sort of just having your hands out and actually using a controller.
I think the thing to add to that, Tom, is that the fact that we do use the OpenVR, it's reasonably straightforward to integrate any emerging technologies as well. So if something new comes along, it's always, it's reasonably straightforward to integrate that into the system, isn't it?
Yeah, so the event system with Steam VR or OpenVR is actually, we basically just tell it what controls you need. And then when new controllers come out, you can basically add them yourself and just say, we'll teleport up to this, we'll interact up to that. And you can pretty much just add whatever. Okay, so the next one is, did the students get a sense of urgency out of the training scenario?
The sense of urgency is completely up to the instructor. They dictate the pace of the event. You can skip ahead to the really urgent part of the mission, or you can run it in real time for hours at a time if you want. It really depends on what the instructor is trying to teach or evaluate. Personally, the immersion level with all the sounds and the visuals, you really do get a sense that you're there. And if the pressure is on and the communications are flowing like they would in a real airdrop, then yeah, I would say that's the whole idea, is to create that sense of stress and urgency.
Yeah, I can say seeing videos of VR never does it justice. Putting the headset on and actually experiencing it for yourself really does show you just how immersive it is. So the next question is, did the student feel they were missing the manual haptic feedback in using the controllers?
That's kind of the point with, we highlighted earlier with the comments from Air Force leadership. You don't get a full sense of grabbing onto the cold metal steel of the controls, but that's not necessarily required to learn a procedure. And the controllers do a good enough job that your brain retains useful information, and the going through the right steps is enough that it's effective, very effective training.
Okay, so the next one is, does the trainer include noise? I suppose we should have clarified that better in the videos.
Yeah, I'm going to turn up the volume here from our studio. Can you hear the high-pitched whine?
Yeah. Yeah, so we muted the videos so that we could talk over them, and to be honest, it can get quite annoying having the airplane noise in the background.
It's quite deliberate. The noises are very loud, so actually you can accurately practice the non-verbal communications.
Are there any standard airland scenarios modeled, or is it entirely based around airdrop?
The focus right now is just on airdrop, but airland and just regular airlift is planned for the future. If this is going to be a full fidelity Loadmaster simulator, then absolutely we want the capability to do onload and offload. But at the moment, there are other ways to do that training with a fuselage trainer or with other computer-based modules. We wanted the first focus to be on procedures that you can't do any other way, and we'll build on other expanding Loadmaster's role going forward. Good example of that is the emergency procedures for just checking the hydraulic systems, regular in-flight checks, responsibilities for the Loadmaster to confirm the landing gear is down, or to manually to check for leaks or anything wrong with the hydraulic systems, is going to be part of 2.0 based on the feedback we got from the current users.
Kind of goes quite well into the next question, which is, are there any customers for this system yet?
Yes, the U.S. Air Force Air National Guard bought the system last year, and like I said, they have version 1.0. We are aiming to get the simulator to every National Guard unit and beyond, so go to active duty Air Force as well.
Okay, so any plans to leverage the system to address rotary wing air crewmen training for payload management, hoisting, and door gunning?
Stuart, do you want to take that one?
So the roadmap moving forward isn't accurately defined. I think the answer to that really is if there's a demand for that type of functionality, then it's certainly something we can look at doing. And we've definitely got the capability to introduce that type of functionality.
Okay, so the systems used are specific to US capabilities. Is it possible to adapt this to different nations' aerial delivery systems, and how easy is it to update when systems or capabilities change?
Absolutely, yes. For example, the checklist, everybody uses a different type of checklist. The plan for VLTS is to take a document file and just drag and drop into as checklist changes or checklist is updated so that it's reflected accurately in the sim. Different payloads, we're continuing to expand the types. For example, you can see on the screen, we've got a list: container delivery bundles, Zodiac, Humvees, ATVs. If there's a request for a specific type of payload, that sort of expansion will be part of the annual updates or regular software updates that go along with the support for the software.
I think from a procedural point of view, what we probably need would be a level of end user engagement or subject matter expertise if there's specific procedures that would need models. But it is an evolving product. You know, hopefully the system's popular. We'll build up that user community, and these type of things we'll be able to implement.
Okay. Is it possible to run gear and flap emergency lowering procedures?
It is possible. We have looked at what those procedures are. At the moment, we've got that all simulated from the instructor console to just kind of happen at the push of a button. The visual indications are there, but in terms of securing the main landing gear and doing the manual release, that's all possible, but it's not in version 2.0 as of right now. Again, that would depend on the user requirements and if that's something they wanted to include.
It's probably worth noting that a lot of the version 2 requirements were driven by our end user customers at the moment. They were very influential in determining, you know, what went in and what didn't.
Yeah, exactly.
Okay, so we've already kind of covered this. Is there any plans to extend this to support training for loading and unloading of cargo?
Yes, not in version 2.0, but down the line. And I'll say we also plan to expand into jump master roles. So for paratrooper static line, doing the equipment checks, calling up procedures, using the hand signals, which is a big part of jump master communications. That's all ideas that will go along with this system. And in fact, Stuart, do you want to explain a little bit how the system was based on doing other roles like the Loadmaster and so like the paratrooper sim?
Yeah, I nearly jumped in, then you beat me to it. I think I touched on it earlier that we do have a number of other VR type products, most notably our marshalling trainer and our parachute trainer, and they're all developed in the same software engine. I think one of the good things about it is the ability to, you know, reutilize some of the assets and the architectures in the software. So I say a lot of the graphical and that sort of side of stuff's been developed. So certainly, you know, things like this additional functionality, different roles, is all very, you know, all very feasible.
Yeah, in fact, you can see on the screen, there's, you know, stations for 24 paratroopers. So we've actually tested putting a combined paratrooper scenario with the Loadmaster. We have equipment going out, you know, paratroopers practicing their emergency procedures under canopy and going through everything because it's all built from the same software engine.
Yeah, there is functionality there. I think, you know, moving forward, the whole collective training with, you know, multiple people in the same scenario, jumping out of different aircraft, doing different roles. That's the plan.
Yeah. Ultimately, we want to offer the end-to-end cargo aerial delivery virtual training from onload to offload to combat offloads, doing very dynamic situations on runways and airdrop, of course, including personnel. So it's all part of the plan.
Okay, so will it be possible to upgrade early generations to later generations as advancements are made?
In terms of hardware, Tom, do you want to touch on that?
Hardware, again, because it's all in the same engine, the hardware should last for a number of years before needing replacing. But I mean, the VR and things do make advancements very quickly, so it all depends. I mean, we try and use the best and most up-to-date hardware that we can so that it does last quite some time. But yeah, it all depends on what headsets and things come out and basically where it goes. But I mean, software-wise, it can definitely be upgraded. And then say worst case, it's you're buying a better headset or buying a slightly more powerful PC or upgrading the stuff you have. So there is always an upgrade path.
I think the same applies for the software as well. We've one of our parachute customers here in the UK. We've recently completed a midlife upgrade on their system, which included hardware and software. And I say with the risk of getting into a sort of commercial wranglings, a lot depends on what sort of package you've got.
Okay, so we've got number one that was you've spoken at length about airdrop and product. Looks like a significant leap forward from what we currently have in place for C-17 Loadmasters. Would there be any move towards standard airland operations, loading and unloading, to reduce the need for very expensive cargo compartment trainers? So again, that's a yes. It looks like we're getting a lot of interest for that. So
yeah,
I think will be version 3.
Yeah, well, I think it's all back to that encouraging the engagement. So if there's specific things you like to discuss, then I encourage you to get in touch directly, and we can maybe have these more detailed discussions.
The more interest there is as well, the quicker we can start working on these things. So that's always good.
Yeah, I know certainly here in the UK, we've already had some initial discussions with some of the squadrons that we're sort of friendly with, and I know that the demand is there. So if collectively throughout Europe or the rest of the world it's there, then hopefully moving forward that can be sooner rather than later.
Definitely. So what should an Air Force expect to receive with a purchase of this system?
Well, you receive a software license. And then the hardware itself is between 3 or 4 desktop PCs with high-end graphics cards and CPUs, a bank of touchscreen displays, and then 2 VR headsets. So the idea is that you would have a set for 2 Loadmasters to work together.
I think the answer to that as well is it's flexible. It can be potentially a purely software-only deliverable, so you'll get sort of media to install it, or we can do the hardware and software. Very much depends on what your requirements are.
It's a very scalable system as well, isn't it? So like we said, you can use it in a very small room with 1 Loadmaster, or you could have the whole plane covered with 2, or even have the ICCs as well, so you can train up to do procedures with 4 Loadmasters at once.
Yeah, definitely, and it's all COTS hardware, which I think is an important part to mention.
Okay, so as new scenarios get added, will there be an upgrade package included in the purchase?
Sorry.
Well, whatever is the current version will be what's purchased.
I think it comes down to again, with the risk of going commercially, what is purchased. We can start with buying an upfront proprietary license and then annual fees to do a level of upgrades and service level agreements, or there's potentially other options that we can consider as well.
Okay, we've got, have you considered a malfunction after release, i.e. single load with a mid-air release, or multiple payloads and the first malfunctions?
Not sure what's meant by that. We do have a load for a sequential release. I'll show that here. It's a dual dual Humvee sequential release.
There is a fault with the dual Humvee that lets you disconnect the front and back Humvee as well, so that if they're not connected and the Loadmaster misses it, the first one will deploy and the second one won't.
But something like that, a specific fault that we may not have covered, again, that's something we could implement. You know, that we are very receptive to user feedback and implementing those sort of scenarios. I saw a question about or grading or catching mistakes.
Have you got yeah, we can show the assessment log if you ran anything on that.
Let me see. Hold on.
So basically, as you run through a scenario, it keeps a log of everything that so either that the instructor has triggered or turned on or off or done, and everything the student does. And on that log, it will flag up anything the student does wrong as well. So if they're in front of the load when it deploys, which obviously would be a very bad thing, that shows up in red text saying that they've done that. If they go past a certain bulkhead in the plane without tethering up, or just a various number of things that if they do wrong, it flags up. There's also that if they drop something out the back, so like in that video where he dropped his knife, that would also flag up in the log. The after action replay, you can watch it from the student's perspective or any other angle, and you can bookmark as you're going. So the instructor, sorry, could be watching the student as they're doing it live and basically go, I'll bookmark that and then go back to it later, show the student and say, here, you should have done this first, or whatever. They can, they can run through it several times and really analyze everything.
So on this screen, you have assessments. You can load assessments from various previous events. You select it, and then it gives you a readout of everything that happened. You can review the timestamp when this happened. Everything bad is highlighted in red, and you can see exactly what happened.
Okay, we've got, have you any plans to incorporate additional Loadmaster duties such as exterior pre-flight duties?
Yeah, I'd say that goes along with the onload and offload. The full exterior of the C-130 is modeled. If there needs to be more detail, again, we can look at that, but doing the walk around inspection and the pre-flight is all possible based on what the users want to see.
Okay, we've got are you going to put this webinar online to share with others? So yeah, it is being recorded, and I think links are going to be sent out later, aren't they?
Yeah.
Next one. So got, hey Jared Stewart, I really enjoyed watching, felt like it was realistic. I had a great interest in seeing how it actually works and really helped out clear some queries. I have one question. Does VLTS show any sort of errors which you make during airdropping? So we've just shown the log there as well. So in an emergency scenario, when we're flying on high altitudes, does the system remind you whether you were performing an action incorrectly, or any alerts if there are malfunctions during the procedure with airdropping of packages?
It would alert the instructor on the instructor console. So on this screen, it would flag any unsafe actions, depending on the parameters we program into it.
Yeah, we tend to leave it to the instructor to to decide whether or not they want to tell the student they've made a mistake, or kind of let them finish what they're doing and then run back through and explain what they did right or wrong. Okay, so we've got, you mentioned integrating the VR system with front-end simulator missions to combine pilot and ALM missions. How easy is this to do?
Sounds like one for you, Tom.
Well, we can basically do anything given enough time. So it's one that we want to do because, well, I mean, from my point of view as the lead programmer on it, it would be really cool. So yeah, definitely interested in doing it.
I guess a lot.
Yeah, it's the software has been designed with that in mind. So there's future growth, and that was left in deliberately for that capability down the line.
Yeah, as we've already showed, it can integrate with sort of jump masters, load masters. So yeah, there's no reason why we can't sort of integrate it with sort of controlling the actual plane and everything as well. It's pretty much built to plug into whatever we need it to.
I guess a lot depends what it is as well, doesn't it?
Mm.
Yeah, of course, it depends. Classic.
But anything's possible. So we've got a, how long would it take to produce a C-17 synthetic air land training package?
I think a lot.
Yeah, I think, Tom, you had given a ballpark just for the artwork.
Yeah, depending on how complex it is and how similar certain parts of it can be to the stuff we've already done, it's potentially sort of, I'd say 6 months of work if we were starting from scratch with the C-17.
Yeah, and concurrently going along with that, we want to talk to subject matter experts and get details on procedures. So probably a minimum of 6 months.
We do some pretty extensive data gathering as well, don't we, sir?
Yeah.
I think you said it already, a lot depends on the required functionality. What I would say is we do have some C-17 assets developed within some of our other products. However, that's more from the externals as opposed to the sort of the fidelity required for the inside.
Yeah, it does. It completely depends on how much needs to function. Because for things like at the parachute simulator, you only really need the visuals for the internal of the plane. You don't really need to be able to do much. But when it comes to things like the Loadmaster, quite a lot needs to work. So it can be a while, but yeah. So I think 6 months or so is probably a good ballpark. And then there's any plans for the system to be linked to existing flight deck simulators for combined training? So again, we've kind of said that it's basically up to the customers what we work on next, really, isn't it? And
yeah, and depending on what system it is, it could really impact the timeline for that development. But it's all, we left that possibility open because we knew there'd be interest in. There's a number of different systems around the world. So yeah, possible.
There's a question in chat about lead time for software development when looking at new disciplines as well. So again, that's very much depends on what it is that we need to develop, doesn't it? So
yeah, I think I'll make the same statement again. We'd encourage sort of the specifics to be fed back into us. And if you've got a genuine requirement, then we can analyze that in more detail and give you an accurate sort of representation of how long and that would be.
Definitely. Okay, I think that's all the questions.
Yeah, we went a bit long, but it was we want to make sure we answered everything. If you didn't get a chance to ask a question or there's you want to follow up with us offline, please do so. We're happy to talk with you. We're obviously very all passionate about this project. It's new and exciting, and we really think we have something to offer the airdrop community. Any parting comments, Stuart and Tom?
There's one more question that's just popped up.
Can you import 3D data using CAD data for a new platform?
Oh, that's an excellent question.
If in most cases CAD data is very, very high resolution and doesn't tend to run well in VR, it's definitely really helpful for us because obviously it shows what everything looks like, but there is still some time on those models where artists have to either redo them or kind of reduce them to sort of game ready. But it definitely is helpful.
Yeah, if you're familiar with the buffer stop assembly, which is the barricade that goes in the front of the aircraft for a container delivery system, that's a piece of equipment that Capewell makes and was pretty much brought into the sim via CAD modeling. So we have the engineer drawings here, and we shared them Pennant. They touched it up, and that is the buffer stop that we designed.
Same with the platforms as well, wasn't it?
Yeah, same with the platforms.
I think they were remodeled, but the CAD data makes that much quicker and easier, and obviously much more accurate as well. So the CAD data is definitely really helpful.
It's also something we've done for our sort of wider software products outside of the VR is taking the higher ends of the CAD model and drop them into the graphics and use those as a VMT. So it's all there and it's all proven technology.
Right. Just to reiterate, this will be posted, so look for a link recording the video. And thank you so much for joining us. Thank you for your questions and feedback. We hope that we can continue the development and give you more updates in the coming months.
That's great. And I'd echo that as well. And I'll thank you again, Jad, for letting us participate in these couple of sessions this week. I think it's been fantastic to jointly showcase the functionality, and it's not quite until you see it on the screen or collectively you appreciate what a great product it is. So we're looking forward to continuing the product and look forward to engaging with all of you that have participated today.
Yeah, definitely. Thank you, everyone. And yeah, look forward to putting lots of cool new features in.
All right, take care. And if you get a chance to try out VR for yourself, you gotta see it for yourself. It doesn't come. The screens here, webinars don't do it justice. How realistic and fun it really is. So that's your homework assignment. Go try on some VR. Have a good weekend, everybody. Thanks again.